So yeah, let's name this demo session, and you have to enter passwords which I'm not disclosing here. Yeah, and you can test your connection. It says successfully made the SQL connection, and then click on OK. And then you see there's a button here which says demo session. So if you double click on it, uh, this window here appears. I have another session open, and that's why it's showing demo. But this is the one that I opened currently. And then you see these are the different panels which you can choose to select C or not. This is the output panel, wherein the output will be displayed, and this is some other SQL additions. This is hardly useful right now. These are important uh, things called schemas, wherein you can store your data. And this is the button where you can introduce a new schema. So you click on this, you name your schema, let's say DAT for data, and you click on apply. Oh, DAT already exists, so it's giving me an error. So let's say DT, and click on apply. And then these are some default buttons. You can click on. One sec. Yeah, you can click on apply, execute SQL statements, and finish. So you see this DT schema is now right here has been created. You can double click on it, and you'll see it's bold. So right now, if it's bold, that means the it's currently selected, and the new data that you'll enter will go into this. So the data set which will be shared in the problem statement will be basically a CSV file, which stands for comma separated list, which is basically if you open an Excel, which would look quite similar to this. It would have different columns, which I'll be explaining later. But this is an example demo file, CSV file. So if this is basically a table containing the team names, a member A column, a member B column, and their scores, which is like this is a demo data which I've taken just to demonstrate. Let's say I want to introduce this table into this MySQL DT schema. So you see it's bold right now. You can right click on it, and you see this table data import wizard button pops up. If you click on it, you see then you can choose the file which you want to import, and then you can click on browse, and let's say I want to choose this demo file. Click on open, next, create a new table, next, and then yeah, you see this is the preview of the table which you want to enter into the schema. So the team name, member A, member B, and the scores. Click on next, and then again, see this is done processing. 6 records were imported, and finish, and then yeah. So right now the data or the table has been loaded inside the schema. You can right click on it and click on the schema inspector just to check these. This contains all the information of what data is inside the schema. So you can go to tables, which shows it contains this demo table. These are the other parameters which you can go through. So yeah, it contains 6 rows and then other information. So yeah, starting on, let's SQL is basically a very similar language to Python, or actually I'd say English. You can go through the syntax which I've included in this doc. This is the tutorial on W3 schools, and also some predefined functions. I'll share this doc later, but yeah, one second. You can go to this site, W3 schools. It has the basic syntax and a lot of other stuff. You can go through all this, and then some SQL functions. I'll demonstrate some basic ones here. So let's go back here. Let's say I want to display all the values in the table. So select basically represents what you want to output out of this query. and star represents all the values. So I'm saying the computer select all the values from, and then this is again the syntax of the language, from demo, which was the table name. And you click shift control enter and you see the pop out result. Basically this is the output. Let me enlarge it a bit. Yeah, so you can see this was a table, and right now this is the query which gave us this uh, output. And well, let's say I have some examples written over here. So yeah, let's say we want to choose all those entries where the score is less than 40, or rather greater than 40. We click on, and you can comment out lines by just introducing a hashtag for the your query. So you see this is commented out right now. So basically this won't be executed right now. If you do this again, all of these values are printed because right now all the scores are greater than 40. Let's say I choose this to be greater than 60. Yeah, all of the columns which have a score greater than 60 right now are printed here. You can see. And let's say I just want to print a particular column. So then I can go to select member A from demo where score is greater than 60. So it'll print all the columns where the score is greater than 60. So if I execute this, see. So yeah, moving on with the next example, you have, yeah, comment it out just so that it doesn't interfere. So yeah, select all the rows from demo where this where represents a condition. Like I think I didn't say this earlier, where the score is was greater than 80. So this represents the condition, like all the rows satisfying this condition. So this is another syntax. So right now it will select all the rows where member A is C1, which means basically this entire row in the data set. So yeah, C1, C2, and well, let's go through this one by one. One second. Yeah. So let me hide this. Yeah. So this all of these pop-up windows are the different outputs of the queries. So semicolon represents one query. So if you put a semicolon, that query is this query is a single entity, and this is treated as a different query. So if you introduce a semicolon, it's the end of the query. So basically, these are different queries which have been introduced because of the semicolon. So if I put this, which means basically to select all the rows so you can see the entire table, this is select all the rows from the table where the score is less than, this basically is 81. I just wanted to introduce the power operator. That's why I wrote this. Power 9 2, which is basically 9 raised to 2, which is 81. So all the columns where the score is less than 81. So this would be this column right here. See? And then this is the count function. If you put count inside of this asterisk, it just counts all the entries wherein this condition is being satisfied. So let's say I want to count what are the number of columns which contain score which is less than 81. So yeah, if I put in this query, I'll get this 4. 1, 2, 3, 4. And then yeah, this is the next one. So select all the entries from the file where member A is equal to C1. I think I demonstrated this one. Yeah. And this is another one. in, which is basically if you want to include multiple values. Let's say I want to select all the rows wherein the score was 100, 80, and 70 exactly. So if I put in this query, I'll get this. Check this out. And another, this one is for if you write between, so that'll give you a range between 60 and 80. So between 60 and 80, yeah, all the columns. So that was some basic SQL for you guys. I'll be sharing this tutorial. You can go through this. And then here are some functions which you can use directly. And yeah, this was about SQL. One second. Yeah, moving on with the data set. So I introduced that we've taken this data set from the NASA Exoplanet Archive. So the data which we'll be giving you would contain the following headers and would look similar to this. We're not revealing the data right now because of the complicacy, because we don't want to reduce the time of the competition. That's why we're just giving you a peek. So this would be the header, and this would be a sample peek into the actual dataset. The dataset would actually contain 2000 values, which you'll have to query and do what's required to do in the problem statement. So yeah, going through the header, we see this. The first column is Kepler ID, stands for Kepler ID, which is basically they surveyed every object and they checked if and they gave a unique number to every object. So yeah, this is basically that column. And the next column is the Kepler name. So you see, there's another column which says COI disposition, which is basically the status of the that object, if that object has been confirmed as an exoplanet or not, or it's just a false positive or just a candidate. So Kepler names are given to all those planets which have been confirmed as exoplanets. You see, so candidates do not have a Kepler name, and same as false positives also do not have a Kepler name. So all the exoplanets in this data have a Kepler name, unique Kepler name. And the next column moving is the planetary radius of that exoplanet. You see, this is given in terms of Earth radii, which means that the radius of the planet divided by Earth's radius. If you calculate that ratio, that's given in this column right here. Period stands for planetary radius. And then the next column is the COI SMA, which is semi-major axis. This is given in the terms of AU, which is astronomical unit. It's a unit of length in astronomical scales. You can check out if you want. This is that column, the semi-major axis in terms of in the astronomical units. And the next column is the COI TEQ, which is the equilibrium temperature of the planet, which is basically saying that if you were to stand on that planet, what would the effective temperature that you'll be feeling. So yeah, that is contained inside this column. And then the next column is star effective temperature, which is the temperature of the revolving star. Like the exoplanet will be revolving around a particular star, and that star's temperature is documented inside this column. COI ST effective. And then the next column is rad, which is for stellar radius. Same, it's also given in terms of solar radii, which means that the star's radius divided by our sun's radius. So if we calculate that fraction, that's all documented in this column right here. So yeah, that's a little about the data set. I can show you the exact data set where we've taken it from. So yeah, this is the entire data set. So we've chosen some of these columns like Kepler ID, Kepler name, and then disposition, like whether it's a candidate, it's a false positive or a confirmed exoplanet. and then a lot of parameters we've omitted because we don't want you to get into that. All the parameters which we've included, you are expected to use them to carry out whatever task we've assigned to you in the problem statement. So yeah, that's all about the session. If you have any queries, any doubt, you can just ask right now or later too. Anyone? Yeah, so we'll be evaluating like your query will produce certain columns of the data set, right? So like I demonstrated in this. So let's say you chose whatever. You wrote a query which gave out this table, and let's say the count was 4, and this was the output. So we'll be matching both the count and the your printed out queries, which are code, with our query, and check how to what extent is that accurate, and then we'll be evaluating. I hope it's clear. Anything else? Anyone?